Okay, everybody, we are going to work our way backwards today. So instead of being given the sides of a rectangle, we're going to solve for the sides. So usually we were given the sides and we had to find the area on the perimeter. Today we're going to go backwards. We're going to find the sides if I give you the area. So let's take a look. We're still under the same algebra content, a lot to deal with polynomials here. So the directions say find expressions for I apologize, I should say the side length of the following rectangles. Then evaluate the area given the variables. So I'm going to highlight this so I can remember to fix this for you guys on your end. And here we go. So this is an interesting rectangle. I see here that the area of this particular rectangle is written as a polynomial, 8x squared plus 10x. So that means that in here, this must be the length with the width already put together. And everything was in terms of feet. So in order to pull apart a length and a width, you need to divide. So you need to figure out what two items, boom, 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 what two items were multiplied together to get 8x squared plus 10x. Give me one moment. I apologize. All right, so in order to do that, we're going to go ahead and we're going to write this in factored form. So we're going to go through the process of factoring. So that means step number one, I better be looking for a GCF. So when I look for a GCF, because that's how you pull something apart, that's how you factor it, you write it as its two factors. I know that 2 goes into 8 and 10, and they both have a single x. So when I divide these items here by 2 and by x, let's see what I have left. Let me get rid of all that stuff. Divide by 2x, divide by 2x. So that's going to turn into a 4x when I take that out. And add 5 because 10 divided by 2 and the x's disappear. Now, what I need you to understand here is that this isn't like to the second power and there's no other GCFs left. So that's prime now, as is this one. That was perfectly fine written that way. So what we just solved for is the length and the width. Now, whether you think that one's the length and that one's the width or vice versa, it really doesn't matter because you can flip a rectangle around. So this one is done. I'm going to write this phrase, no more factoring. I'm going to restate why because this is not squared and there's no more GCFs left. So that is the end. There's no more factoring. So let's see what the other box here says. If x is 1, what's the length, what's the width, and what's the area? And I spelled width wrong every single time in here, so I'm going to change that for you guys. I apologize. On your notes, I will say W-I-D-T-H. So x is 1. That's very interesting. So what I'm going to do is right here in a different color, if x is 1, then what is 2x? So you see how like 2x was one of our sides? And you know what? I should have labeled that. Let's label that. I guess I already did. I had the length as being 2x, and I have the width as being 4x plus 5. So if x is 1, which is from over here, this would be 2 times 1, which would be 2. And this would be 4 times 1 plus 5, which is 9. Just to emphasize, I took the x away and I made it into a 1. I took the x away, I made it into 1. And then I can put my like terms together. Also, I think there were some units. Yes, see how the area was in square feet? So I would have 2 feet and I would have 9 feet. Let's see, since this one's bigger, this would be 9 feet. And then this way, this one would be the 2 feet, not necessarily drawn to scale. And remember, the area would be the 9 times the 2, which would be 18 square feet. So we're able to break it apart. Now, let's say you're like, oh, I solved for my area a different way. Definitely could have used this right here, 8x squared plus 10x, and I'll show you how that works. So it was 8x squared plus 10x. So it'd be 8 times 1 squared, I use parentheses when I square something, plus 10 times 1, which sure enough, guys, either way, whether you do it with the factored parts and then multiply those, or whether you do it with the original, you get 18 square feet. So I have my area, I have the length, and I have the width because I showed all my work. All right, now I do promise they do get a little harder. It's not just a GCF all the time. So over here, this is the given area of this particular rectangle, which means whatever was here got multiplied with whatever was here, and this is the product of what I got. So I need to think, I've got to go old school because I've got a squared here. I have a clear-cut ABC. What is my GCF? Well, in this case, nothing goes into 19. 19 is prime. So my GCF is just 1. So that leaves me with 6x squared plus 19x plus 3. Now I have to go through the process that we've learned before. It's time to break this apart. So how do we write this in factored form to like break it apart into 2 units? We go through our process of A, B, and C. Then we go to our T-chart of AC, which is 6 times 3, which is 18, and B, which is 19. And then we do 1, 2, 3, 4, 5. And we have to, remember, we do 18 divided by 1 is 18. 18 divided by 2 is 9. 18 divided by 3 is 6. 18 divided by 4 is a decimal. And 18 divided by 5 is also a decimal. All right, and now we add the results. So 1 plus 18 is 19. Oh, look, I found my answer right away. And maybe some of you are faster than others, and you're like, I knew it was 1 and 18 to begin with, Miss Lindelli. That's great. Good for you. Not everybody's where you are, so I need to make sure I meet the needs of everyone. So I'm going to go to my box, and the top left, hopefully we have a good memory recollection, 6x squared and a positive 3. 1 and 18, and those get x's. And now I do my GCF here, which is a 1 and an x. And I do my GCF here. And what goes into 3 and 18? Not 6. I know some of you might be tempted to write 6, but the answer can never be bigger than what's in there. So it's 3. Yes, 18 does divide by 3, but like not we don't want the result. We just want the biggest factor. The 18 is positive. GCF here is a 6 and an x. And a GCF in here is just a plain old 1 and not an x because the 3 doesn't have an x. So when I say my length and my width, my length could be the 6x plus 1, and my width could be the 1x plus 3. And those are in feet, just so you are aware. Okay. And now let's look over here. If x is 5, what is the length, and what is the width, and what is the area? Okay. So I'm going to move this one over. I'm going to write them side by side. I just think it looks better that way because then I can fill in better. Yeah, I think that looks prettier. Okay. And in fact, I'm just going to separate them with a little line here. So we know like that's length on the left. Okay. So x is 5. So you see that x? 6 times 5. So that's 30 plus 1 or just 31. What are we measured in this one? Feet? Oh, silly me. I wonder if you guys caught that. I apologize. These were definitely measured in inches. I should have done a double check before I did anything else. So 31 inches by the width, let's see, 1 times 5 plus 3 is 5 plus 3 or 8 inches. So looking at this rectangle, let's see here. I'm going to say this one is the 31 inches. I'm going to say this one's the 8 inches, just looking at it size-wise. But it also asks us to get the area. So the area is the 31 times the 8. Let's see, 248, I do believe, square inches. However, just because I don't want to redo my video, I'm going to give that a shot. Let's see here. 31 times 8. Just double checking. Yeah, I don't like to redo videos. Now remember, if you didn't like doing it the way I did, you still would have to solve. I think it's the easiest way, but you would still have to get those. But then you could do that 6x squared plus 19x plus 3. So you could do, what was it? It was 6x squared. I think it was 19x, and there was a plus 3. So if you wanted to, you could have put 6 with 5 squared and 19 with 5, and then add 3. Now, that's not necessarily math that I'm going to sit here and try to do in my head. The chances of me screwing that up could happen. But either way, what I want you guys to see is no matter how you choose to do that, you would end up with a square inch of 248 square inches. I think the first method, this method right here, is the easiest. This one I would probably not encourage, but you know what I would do? If you are interested, you could just double check yourself. Like I essentially just proved that I was right since I got 248 both the ways. All right, given rectangle again. So I have a length and a width. I have this given area. So remember, whatever's inside of here is the area. If I need to find like what was here and what was here so that I got that area, I'm going to have to write it as its factors. Like I'm going to have to break it apart. So I'm going to go over here. I'm going to look for my GCF. So nothing goes into all of those terms except for a 1. So it would be the same. X squared, add 2x, take away 35. A is 1. B is 2. And this is x squared, and this is regular x, so I can do that. C is negative 35. All right, so let's do this and this. AC is 1 times negative 35, so negative 35. B is 2. 1, 2, 3, 4, 5. Now, maybe some of you already have it. That's great. That's great. Just remember, not everybody's going to be as fast as this as everybody else. So we have negative 35 divided by 1 is negative 35. Negative 35 divided by 2 is a decimal. Negative 35 divided by 3 is also a decimal. Negative 35 divided by 4 is a decimal. Negative 35 divided by 5 is negative 7. Okay, now I'm just going to add those together. So this one gives me negative 34. This one's out. This one's out. This one's out. This one gives me negative 2. Okay, now I want a positive 2, remember? So the big rule is you change, change, change. So there's your magic numbers, your magic factors. Time to go to our box. All right, zooming in, x squared goes in the top left. Negative 35 goes in the bottom right. I had a 7 and a negative 5. This turns into regular x. Divide here. What's the greatest common factor is a 7. Greatest common factor here is a 1x. And greatest common factor, and just x for some of you, you're ready to do that, is a negative from the 5, and 5 goes into both of them. So maybe my length could be x plus 7, and my width, and these are interchangeable, is 1x take away 5, or just x take away 5. That's a little easier. Now let's see what was the units. Inches. So I'm just going to put inches beside this. Now over here, okay, I had to pause the video. Over here I had x equaling 3, and it gave me a negative dimension. So what I'm going to do, we're just going to make x equals 10. That kind of clears any issues up that I was having. So just everybody make x equals 10 here. I'll change that on your notes. All right, so here I have x plus 7. So instead I'm going to have 10 plus 7. So one side has to be 17 inches. And here I'm going to have 10 minus 5, which is 5. So the other side has to be 5 inches. Looking at my rectangle, it would make sense that if this was the side that is 17 inches, and then this is the side is 5 inches. So I did my length and my width, but now I need to do my area, which we know. So to find my area, I have to do 5 times 17, which is 85, and that is in square inches. But if you didn't like that method, you could bring over the original polynomial from over yonder, and then we could plug in, what was x? 10. And you can actually see if you look at my calculator, I'm highlighting it. I already did that. And sure enough, there's the 85 square inches. So either what method works, I think that method's the easiest method. You'll probably agree. But it is nice to be able to do a double check. And what's kind of funny is I actually had to crop this video because I made a mistake. And I found that in my double check. All right, one more, I do believe. So we have this given rectangle here. Holy cow, this is a hot mess. let's see, 1, 2, 3 terms, so it could potentially be a box. I need to write it as its factor so that I can find two separate items that were multiplied together. So I can get like an item for up here and then like an item here. So let's check out our GCF. Let's see, I got 24, 80, and 144. So I'm going to try, I mean, 8 probably is going to be it. I'm going to try 12. I don't think 80 divides by 12. Ah, okay. So I'm pretty sure it's going to be 8 because I can do 24 divided by 8. I can do 80 divided by 8, and I can do 144 divided by 8. And those are all clean cut. And their results, the 3, the 10, and the 18, because the 3, the 10, and the 18, they have nothing else in common. I know I did a good job. So it's going to definitely be an 8 for my GCF. However, I need to go back because I saw they all had some type of x. Let's see. This one has x to the 6th, x to the 4th, x to the 4th. So we picked the smallest exponent. So I'm going to actually have to take out x to the 4th power. Let's go see if they all have a y. No, only in the middle term. And they don't all have a z. So I'm going to erase that y. I'm going to divide out. And I like using that word divide out because obviously that implies that the answer is multiplication. I'm going to divide out that 8x to the 4th. So I'm going to get rid of all of these weird squiggles I drew. I'm going to divide by 8 and take away an x to the 4th every single term. All right, so dividing by 8 is actually over here on my calculator. 24 divided by 8 is, I've got to change that color. I'm sorry, that color is really making my eyes, oh, almost makes it look like 3D. I'm sorry. There we go. That's better, much better for me. All right, so when I'm going to divide it out over here, then I'm going to throw my answer on the other side. All right, so it's going to give me a 3 with an x to the 2nd, because you do 6 take away 4, minus 10 with a y, because when you divide, you get 10, and 4 take away 4 is none, and the y travels down. And then 144, if you look at my calculator over there, I got an 18. X to the 4 goes away, and it has a z. So I'm going to swoop that. I'm going to duplicate that. That is going to fit right inside of here. And now, I'm going to guess there's a lot of you are like, all right, I'm ready. That's A, that's B, and that's C. However, I want you to see something. I'm not going to do that. Okay, I'm going to let go and that's all going to get erased. Because in order for this to like factor this any further, this would have to have a single x term. And then like if that had a y, this would have to have a y term or y squared term. And then that z in the back is super throwing us off. So there is no way that we can do this because we don't have the right variables for factoring. Like this would have to be minus 10x and then just plus 18. Or we would have to be able to get rid of that z or that y somehow. So because we have all those mismatched variables that don't match the rules that we've talked about, we're done. The length is 8x to the 4th. And the width, or vice versa, because it really doesn't matter, is 3x squared minus 10y add 18z. So let's look at what we want to plug in. If x is 2 and y is 2 and z is 4, what's the length and the width and the area? What was x? X was 2. So on this one, x is 2. So I'll do times 2 to the 4th. I'm going to use my handy dandy. Okay, so I have 128. I'm going to do the same thing here, but oof, look, I have a lot of x's. So that's going to be 2 squared minus 10 times what was y? 2 again. I made y the same thing. Sure, why not? Plus 18. And what did I say z was? 4. Pull that from over here. These are just random made up things that Miss Langeli did that hopefully work. I think they will. So we'll do 3 squared minus 10 times 2 and then plus 18 times 4. And look at that, we get 64. Let's check out what our units were. Boop, boop, boop. Inches. Looks like everything was in terms of inches. So I'm going to do inches here. I'm going to do inches here and inches here. There's the length and the width. There they are evaluated. The long side is 128 inches and the shorter side is 64 inches. And now for the area. Remember, there's two ways to do area, right? You can just do the 64 times the 128. Let's do that over here. And then to verify, so, oh my, that's a large number, 8,192 square inches. Now, to verify, I can plug, oh boy, look at this. So for x, I can plug in a 2. Okay, again, x I can plug in a 2, y I can plug in a 2, x I can plug in a 2, and z I can plug in a 4. So I made that x a 2, I made that x a 2, I made that y a 2, I made that x a 2, and I made that y a, or that z was a 4. And to verify, I think it's neat. Maybe you think it's just overdone. I think it's neat though. Minus 80. Oh, lots of typing here. Plus 144. Hopefully I haven't missed anything yet. Sometimes I feel like I make mistakes and kids wish they could say like stop. All right, hopefully I typed that in exactly the way that I have it. And when I hit enter, I get 1,000. Oh dear. Well, what did I type? Oh, look at that. I forgot. I'm sorry. I missed my Y term here. Did anybody else notice that? I forgot this too. There it is. That looks better. So no matter what, I get 8,192 square inches. Obviously, this method was much shorter and easier. However, I at least confirmed it using the other method. So if you like steps written out, here they are. Step 1, you need to find the factors. That's just like the goal. The goal is to find your factors because you have the product. In order to do that, you need to do the GCF. And then if you can, I'll write if possible, if it matches everything we've done, you need to do A, B, and C. And then you need to complete the box. You need to complete by using box method to finish finding, this is long, the factors. Oops. And then you need to, step 4, plug in given values if there are any. And that is today's lesson in a nutshell.